Okay, this is the second video on parametric equations, and example number 4. We're going to graph and eliminate the parameter. So we're looking at x is equal to a plus b cosine theta, and y is equal to c plus b sine of theta. If we solve for cosine theta and sine theta, we have x minus a over b is equal to the cosine of theta, and y minus c over b is equal to the sine of theta. Okay. If we use the Pythagorean identity, cosine squared plus sine squared is equal to 1. Then we have x minus a over b squared plus y minus c over b squared is equal to 1. And if we multiply everything by b squared, we have x minus a squared plus y minus c squared is equal to b squared. And so this is generically a circle of radius b centered at AC, and we're making the assumption that b is in fact positive. Okay. Alright, so here's our center of AC, and then our radius of b. If theta is equal to 0, then the sine of 0 would be 0, and so we would have our y-coordinate at C, and the cosine of theta would be 1, so you'd have a plus b, so this over here would be a length of b. Okay. Now at pi over 2, the cosine is going to be 0, and so our x-coordinate would be at a, and then our y-coordinate, the sine of pi over 2 would be 1, so we'd have c plus b, so we'd have a length of b there, and that would tell us a counterclockwise rotation. Okay, alrighty, and so that's our first example. So we have a circle more generically. We had the circle in the previous video. Let's look at another one. So we're going to look at x equals a plus b cosine theta, y equals c plus d sine of theta. If we solve for both the cosine and the sine, x minus a over b is going to be equal to the cosine of theta. Y minus c over d is going to be equal to the sine of theta. Using our Pythagorean theorem, cosine squared plus sine squared is equal to 1. And so this is going to be an ellipse centered at AC. We're going to also make the assumption that b and d are greater than 0 here. Okay, so here's our center of AC, and then we're going to go b left and right. That may be our major or minor axis. It depends on which one is larger between b and d. Okay, and then our minor axis or major axis depends on which one's larger. We're going to go d in both directions. We'll put our ellipse in, and we can go ahead and kind of see what the orientation is. So if theta is equal to 0, then x would be equal to a plus b, so that would be right here. And the y, well, I didn't say the y, but the y would be equal to c. Theta is equal to pi over 2, then the x would be equal to a, and the y would be equal to c plus d, and so that put us right there. And so we'd have a counterclockwise rotation there. Okay, and so if you have different values for your numbers, then you can always do something like this to see what orientation is going. All right, I think we got 2 more, so we're almost done there. Alrighty, so moving on to the next one, we're going to look at x is equal to a plus b secant of theta, and y is equal to c plus d tangent of theta. Okay, and then again we're going to make the assumption that the b and the d are going to be greater than 0. We're going to solve for both the secant and the tangent. So secant is equal to x minus a over b, And the tangent is going to be y minus c over d. We're going to use a different Pythagorean identity, which is going to be tangent squared theta plus 1 is equal to the secant squared of theta. So we have y minus c squared plus 1 equals x minus a over b squared. And if we rearrange that, that's going to be x minus a over b squared minus y minus c over d squared. And that's going to be equal to 1. This is the equation of a hyperbola. Centered at AC. Okay. Now, notice the x term here is positive, so that's going to tell us that we're going to be opening left and right. If the y term is positive, then you're going to be opening up and down. Okay. So here's AC. And then for graphing purposes, we're going to go left and right, b units. We don't know how many units that is. And then we're going to go up and down, d units. And in both cases, that's from the center. Usually, I think this is called an auxiliary box. We're going to draw an auxiliary box. Your asymptotes will go through the center and the diagonals of your auxiliary box. Okay. And then your vertices are going to be at, let's see, a plus bc and a minus b comma c. Okay. And then you'd have to play with some thetas to kind of get an idea of the orientation here. So the orientation is going to look like this. Okay. So again, pick some values of theta and kind of see how it goes. You know, theta is equal to 0, pi over 6, something like that. And then you're going to probably have an abrupt change at the asymptotes at pi over 2 and 3 at pi over 2. Both the secant and the tangent have that. So take a look at those, and that'll kind of help you with the orientation. All right, let's go ahead and do one more. So x is equal to a plus b tangent of theta, and y is equal to c plus d secant of theta. Again, we'll make the assumption that I hit the wrong button there. Okay. We didn't see all that just yet. Okay, we're going to make the assumption that b and d are greater than 0. Okay. So solving for tangent is x minus a over b. Solving for the secant, it'll be y minus c over d is equal to the secant, and of course I mean secant of theta, tangent of theta. Okay, using our identity, tangent squared of theta plus 1 is equal to secant squared of theta. So that gives us x minus a over b squared plus 1 y minus c over d squared. And we'll solve that for, well, we're going to solve it so that the 1 is positive and by itself. So we'd have y minus c over d squared minus x minus a over b squared, and that's equal to 1. And this is also a hyperbola. The y is the positive in this case, and so we're going to be opening up and down. And this is centered at AC. So we're going to center at AC. We're going to go left and right b units, up and down d units from the center. And we're going to draw our auxiliary box. And your asymptotes will go through the diagonals of your auxiliary box and the center. Okay. This time your vertices are going to be at a comma d plus c and a comma c minus d. Okay. And then again you can go ahead and use your values of theta to kind of get an idea of what is going on in terms of the orientation. So let's try and see if we can kind of follow the orientation here. So do our theta, and we're going to graph the tangent of theta and also the secant of theta. And the period of tangent is pi, the period of secant is 2 pi, so we'll graph it on 2 pi, so we get a full period of the tangent. 2 full periods of tangent and 1 period of the secant. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So the tangent is going to go 0 vertical asymptote, 0 vertical asymptote, and 0. Secant will go 1 vertical asymptote, minus 1 vertical asymptote, and 0. So we're going to go ahead and try to sketch this and kind of get a motivation for the orientation here. Okay, so let's put our asymptotes in. Alright, then we'll start with graphing the tangent. So the tangent's going to kind of represent our x. So it's going to start at 0. And so that would 0 is going to be actually here or here. A is kind of where the center is. So, and then it's going to increase up. And so it's going to increase up. So it's going to be either this one or this one. So positive from the A. Okay. And then it's going to go down like this, so negative. So it's either going to follow this, negative to the 0, negative to the 0 being the A. And then it'll start going positive. Okay. And then another negative to 0. And then let's graph the secant. So the secant is going to start at 1, which is going to be the maximum, so that's going to be C plus D. And then it's going to go positive in the y direction. So that is this. These two here are going to tell us this. Okay, and then the second part is all the y's are negative. So that's going to be this portion down here. Oops. And finally, we're going to have a positive portion. That's going to be up here. So let's go ahead and draw those in. Okay, so your x is positive, that's red, and your y is positive, which is the orange. So where they're both positive is going to be that first branch right there. Okay, right here. Okay, and then we hop over asymptote pi over 2, and both the x and the y are negative, so where that's going to happen is down here in quadrant, sort of like a quadrant 3. Okay. All right, and then on the other side of pi, the x's are positive with respect to a, and the y's are negative with respect to a. Okay, so that gives us this portion down here. All right. And then finally the last part, the x's are negative following the tangent graph, and the y's are positive following the secant graph, and that gives us that last piece right there. And then this is going to keep repeating itself, so you're going to have the rest of the secant graph being positive here, and then the rest of the tangent graph being positive here. And so that's going to give you a repeating of that there. So hopefully that helps a little bit with understanding the orientation there. Okay, so that's it for this video. Stay tuned for 7.2.